we thought really long and hard about our business model. And, we started off as a protein company. And then I remember we were pitching Vinod Khosla, who's like sort of one of the legends in Silicon Valley. And he said, you'll never be $1 billion company if you don't have a branded consumer product.
Hi guys, and welcome back to another edition of the Paxtier Podcast. We're really excited today to bring you a chat with Beth Zotter, the CEO and founder of Umaro. Umaro have been making alternative bacon from seaweed for the past couple of years, and the product is now found across the US. But this team is involved at all stages of the value chain, including offshore farming and strain optimization. We spoke with Beth about all these points and so much more. We hope you guys enjoy it. Let us know what you think, and let's dive in. How's it been since we last spoke? I think it must have been 6 to 8 months ago, or maybe even up to a year ago when we last caught up.
Sure. Well, some of the biggest things that have happened in the last, it's a year and a half. Well, first, let me just say what our company is about and why we exist. So we started the company based on the realization that seaweed will inevitably be the world's future protein source based on first principles. And those first principles are higher photosynthetic productivity versus plants on land, higher access to nitrogen. So ocean contains 80% of the world's chemically reactive nitrogen, which is the building block of protein, and the ultimate scalability of the ocean. So that we look at the ocean as the Earth's most scalable protein bioreactor. And so our goal as a company is really to build the technology stack to unlock that resource as the world's future protein. And there's a lot of elements to that. We're a long way away from it, but based on first principles, seaweed will be our future protein source. And I like to quote my co-founders, Amanda Stiles, and she likes to say, there's a reason why in all the sci-fi movies, everyone's eating algae. Makes sense, right? So there's a lot of work we have to do to get there, but there's a lot of really important implications for a shift from protein production from land to sea. And we're really excited to be working on some of those key elements of it.
What are some of those key elements? Because I know you've got a few involvement, a few roles in different parts of that value chain, but what specifically are you guys working on?
So, I'll say sort of what I think the 4 key elements are of that technology stack. The first is biology, right? We need to build high protein strains that are fit for purpose. And there's a huge opportunity there. I think there's a lot of low-hanging fruit. We're excited to get started on that. We haven't started working on it yet, but hopefully soon. The next layer in that technology stack is the farming technology, which is actually how our company got started. So we got started with a $6 million grant from the U.S. Department of Energy's RBE Mariner program to design and engineer offshore seaweed farms. I'll talk about that in a little bit, about what we actually accomplished there. But the next layer is the processing. So right now we have a lot of availability of basically whole food. But if you look at the terrestrial farm agribusiness industry as an analogy, most of that agricultural production is fractionated in some way. So if you look at the way that a soybean is fractionated into its component parts, like soybean oil and protein, we need to start looking at how to do that with seaweed so that we can expand the market volume and value for seaweed. And then finally, it's the formulation of those components into value-added products. So food and materials are obviously huge applications for that, but I'm really interested in seeing new applications and new uses of seaweed. And that goes all the way back to the biology part, right? We want to design new cultivars that are fit for the end purpose. And I think given the variety of seaweed species and molecular compounds that are available, I'm really excited about all the opportunities there are for sort of designing new materials and new foods as well.
Do you see any trade-offs with modifying the seaweed? So, for example, if you increase the protein, would there be decrease in something else? Or do you envision any difficulties when it comes to engineering your strain?
Yeah, so I think the low-hanging fruit is not engineering. It's actually just traditional breeding. I think we're not even yet at the point where we have enough information. So I think even though most of the commercial food species have probably been sequenced for the genome. Before you start doing genetic engineering, you need to understand the function of those genes and what they do. I don't think we're there yet for most of the major commercial species, but I think what we start off with is just using traditional breeding techniques to select for species that have, select for cultivars that have the desired traits. So for us, we're really interested in boosting the protein content in commercially important species.
Are you still pushing ahead with dulse? And I know that dulse can get up to, 50% protein content sometimes, maybe in the lab. I'm not sure if that's in nature actually how it is, but still the main focus.
So we actually started with nori, and that's what we scaled up. From the beginning, we were really looking at what are the species and the supply chains that can scale in the near term. And just because nori already has a very large and established supply chain, that's the species, and also a very high protein content. That's what we're currently using in our plant-based bacon. And last year, so the first question you asked me, sort of what's happened since we last spoke. The two big things are that we demonstrated a whole suite of advanced technologies in an offshore environment last year in the Gulf of Maine. And I'm excited to tell you about all the components of that offshore technology. And then the second aspect is we developed a new market. We are the first company to commercially manufacture a seaweed protein ingredient and integrate that into a food product. So, we make a plant-based bacon, and we use that as a way to integrate the protein into a food product. And so the way that we see that food product is really, we're using bacon to introduce consumers to the world's future protein.
Awesome. So tell us a bit more about the offshore tech then. I was going to say, I'm desperate to hear about what that means and dig into it.
So the company actually started with the grant from the Department of Energy. And at the time, we weren't looking at protein. The Department of Energy is interested in seaweed for biofuels and wanted to fund technology development around offshore farming that could enable a future seaweed biofuels industry. So the challenges that we were given as a team there was three. One, it had to go offshore, which means it had to be robust to offshore waves and currents, high energy environments. So we needed to design a structure that could survive those conditions. The second one was it had to be safe for marine mammals. So rope and buoys pose a hazard to marine mammals, especially whales. And operating on the East Coast, we were particularly concerned about the North Atlantic right whale, which is an endangered species. So we went back to the drawing board and say, how can we build a structure that did not have rope, which was sort of a radical concept. And then the third aspect was also really important is nutrient access. So as you move offshore, nutrients become very scarce in surface waters, especially during the summer, when is your prime growing season in any sort of agricultural industry, because you need to have light. This is the number one ingredient for photosynthesis. So we had to think about creative ways to access the high nitrate concentrations that are below the thermocline, so that are about 50 to 100 meters below the surface. So what we developed to solve those challenges is, first, we developed a structure that had multi-line helical anchors. And so that was something that no one actually has ever done before, to our knowledge. Most anchors right now are done with drag embedment anchors, and helical anchors are generally used for smaller, like boat moorings and stuff like that. But we developed two things to enable an arrayed mooring structure. So the first thing we did was we actually had to build our own robot. And so our partners on that project, we had our other lab and the University of New Hampshire. So they did most of the engineering of the structure. And other lab came up with a robot to install these screw anchors because we had no other technology to do it. So they're now commercializing this anchoring robot, which will enable a whole suite of other offshore technologies for moorings. So that was the mooring side. We developed a structure that was like an array. So it's scalable and modular, which is really important because most seaweed farm designs right now, they put all the mooring tension on the perimeter. And so as you scale something bigger and bigger, if all your moorings are on the perimeter, that increases the strength and tension requirements on the inside, right? So what we did was essentially made an array, like if you think about an array of like a solar farm, so that the moorings are essentially scattered throughout the grid. So that was sort of a totally new design that we developed. And then on the marine mammal safety, we actually built the farm out of composite fiberglass rebar. So I didn't know what this material was before I started looking at this, but it's essentially like, if you think about the material properties, are essentially like a piece of dry spaghetti. It's very strong and sort of rigid and it bends, but if it hits a certain bending radius, for example, if a marine mammal is encountering it, it will snap. And so it won't loop or wrap or form knots, which is the principal way that marine mammals are entangled in aquaculture gear. Mm-hmm. So we built the farm out of composite fiberglass rebar, and our partner Other Lab developed a totally new system for deep water upwelling. So it is essentially, if you can think of a underwater ceiling fan meets a one-way valve, it's wave powered. And as the buoy at the surface moves up and down, it pumps, essentially using hydrofoils, it pumps deep water nutrients to the surface. And so that technology was demonstrated actually separately in California last year, but our first field test demonstrated upwelling flow rate that was 100 times greater than any previous upwelling technology that had been demonstrated before. So truly revolutionary technologies across the board. And so what we're doing now is we're developing and commercializing the component technologies separately, but we're essentially open sourcing that design. So we want to see the industry adopt these scalable construction materials and designs so that the industry can flourish and that the cost and scale of seaweed can start approaching those other major industries.
I have so many questions. That was really cool. Thank you for that explanation.
I usually have pictures. Maybe we can include those later in the podcast. But
I know we absolutely should, because I didn't know what some of the things you said meant. So I mean, it'd definitely be helpful to see some pictures. You said that it's moored. Like, what kind of depths are we talking about? Like, there must be a huge amount of strain if it's like right near the surface and it's moored. I don't know. Offshore must mean more than 200 meters or something in depth.
So the design is ultimately scalable to any depth. And so we originally planned to demonstrate it off the coast of New Hampshire with our partner, University of New Hampshire. Ultimately, we had trouble getting that permit, so we moved it to Maine at a partner location. So the location where we installed it was not that deep. It was only 40 feet, but it was fully exposed to offshore waves. And actually, the structure survived 20-foot waves in a nor'easter storm in 40 foot of water. So if you can just think about the strength, flexibility required of a structure to withstand that, that was a great demonstration of the structural engineering that went into the system because it survived it.
What's next for this tech, Beth? Is this the future of US and Western Hem everywhere seaweed farming?
I hope so. So right now, farming is not part of our business model. It's how the company got started. It's how we developed the thesis around protein over time while we were building this farm. But our goal is to transfer this technology and the know-how and the knowledge to the supply chain. So we're eager to, begin discussions with people in the seaweed community, companies that have the interest and access to ocean space to demonstrate these technologies and that have a desire to scale.
So what hectareage can we meet with this? Is it something that can scale to massive areas, or is it going to have serious limitations to nutrients or other?
It depends. The other requirement for the RPE grant was that it needed to be able to scale to 1,000 hectares. So this, on a technical level, this design could scale to 1,000 hectares, but as you're mentioning, it's what's the nutrient profile of the location, and so that's highly dependent on the specific geographic location. But as a structural design, because it's modular and because it has that grid-like property, it can continue to get bigger without increasing loads on individual anchors, which was the key thing that we were trying to achieve with this modular design.
Sorry to keep asking farming questions. I know you guys are, it's not your focus, but
No, but I'm
my
super
final question.
about it. It's the screensaver on my phone is our.
I was wondering, the way you talk about it, do you think that a big thing currently limiting, getting enough biomass and seaweed cultivation is that there's not kind of standardization of farms? If there was a design, say your one, that was universally accepted, do you think we could really start to ramp up production?
Yeah, I mean, I think the costs of doing something new and every time having to engineer something and do bespoke farm deployments each time is a huge barrier. I would love for the design that we've started, which is really just a Gen 1, to become something that is commodified and easily packaged, that all the auxiliary construction equipment is all sized correctly to do it. Yeah. So, we have all these components that we made for one time. We now have the blueprint for that, but we're really interested in finding people and partners who can take it to the next level.
Yeah, I think that's a really interesting point, because you see so many people just coming up with new designs. You must think the amount of time, and just as design, effectively it does the same thing. But no, maybe there needs to be a little bit more collaboration across the board on, look, guys, this is the technology we developed. Can we help each other to take it to the next level, as you say?
We can put like one module or one tile, we call them, of this into a shipping container. One of the nice things about the helical anchors is that it's much lower mass. A lot of people are using gravity anchors, which are extremely expensive and very expensive to ship in addition to install. So, we're specifically designed something that was high strength and low mass. That's helpful for the farm, the cost of the materials, but it also helps in the shipping cost as well.
How far offshore? Obviously, you said 40-meter depth. It's just an idea, right? But to get this seaweed back to shore so that we can create products and sell products, how would you then transport that seaweed? Is it something that has to be factored in terms of like the renewable energy sources for fuel, for shipping, or is that part of the thinking as well? Right?
I think the future looks a lot like sort of the high automation and scalability that we see in terrestrial agriculture. So ideally, we would have autonomous harvesting operations, and marine transport is one of the most energy efficient forms of transport we have. So that's an advantage that, with continued technology development, I think could make it very low impact, low emission harvesting. That's not something that we worked on on our project, but it's something that does need to happen for the industry to really modernize and achieve the potential that it actually has based on those first principles.
What's next for you guys? I know you guys we're asked to talk about what you guys are raising at the moment, right? And speak a bit more about that and what's the plan there?
Right. So we also in the last year launched a commercial food product, our plant-based bacon, which is doing extremely well. It actually we have our product in a bunch of New York bodegas, which are in New York. Bodegas are sort of where every New Yorker gets their breakfast sandwich. They're sort of a combination convenience store and deli, and most people get, breakfast, lunch, or, they're open 24 hours, right? So we have a bunch of data now from these bodegas, from over 40 bodegas that sell plant-based menu options. And our bacon actually has outperformed every other category of meat because, in terms of order volume, because people like to put bacon on everything, right? It's not competitive with other meats. They put it on eggs, they put it on burgers, and they put it on chicken. They put it on cheesy fries too. So the product is doing really well. So, we want to continue fundraising to move to the next level in terms of our commercial operations, but also to continue moving the needle on our seaweed science, on the core technology around separating protein from the seaweed biomass. So we're basically just moving to the next level, and we want to, as I mentioned before, we want to work on biology. That's not in the immediate future, but it's definitely going to be part of the next fundraise.
Are you geography agnostic with your investors? Are you looking for investors from anywhere, or is there a region
in particular that you're looking to invest?
We have no preference for geographic. I mean, we always are interested in having investors that can help us in some way, but there's a number of ways that investors can help. Connections to industry partners is a big one, but also just advice on commercializing a commercial and consumer food product. So our current investors give us a range of those benefits. We are very interested in finding people who can help us. Eventually, sort of the next level on the protein side is building out a manufacturing facility, and that is most likely going to be done as a joint venture with partners that have the expertise and know-how in food processing.
Who have been some of the key partners that you guys have had in your journey?
So our lead investor is AgFunder, which Rob Leclerc led our deal, and he's one of our main advisors. And so he's been extremely helpful in our growth as a company. Our other key advisor is Neil Renninger, who was one of the co-founders of Amyris, and then Ripple Foods, which so he has expertise on both the sort of the upstream manufacturing core biotechnology aspect of things, as well as the consumer product side of things. And yeah, we have just a bunch of great investors. I'm really happy with that. And then on the consumer product side as well, Clear Current Capital is one that invests exclusively in plant-based protein companies. And so Steve Molino at Clear Current, I should shout out to him as well.
On terms of the general industry that you're seeing evolve, you're very involved in the seaweed sector over in the US and everywhere. What's your perspectives on how it's shaping up in the last few years of working in the industry? And where do you see it going? What roadblocks are you coming up against now that you weren't necessarily seeing 1 year ago, 2 years ago?
Yeah, so I think it's important, and you asked at the beginning of the conversation about supply chain and what seaweeds we're using. I think it's important. There's a lot of great activity going on in the Western world around seaweed, but I think we have to keep recognizing that 98% of the seaweed produced for food is in Asia, and that's where it makes logical sense for the next layer of technology to be proved out. That being said, there's a big opportunity to sort of leapfrog, right? Because almost all, I should actually just say all of the seaweed grown in Asia is done at small scale using mostly manual methods by individual farmers. So there's a big opportunity to demonstrate highly automated and efficient, sort of more capital intensive, but also more lower operating cost farming in the Western world where we have very good resource potential in a lot of areas that hasn't been built out. So I think there's there's two things at play, right? I think we need in the Western world, we need to learn as much as possible from our Asian counterparts because they just have so much know-how in the industry. So we don't want to reinvent the wheel. So that's on the growing side or on the production side. But I think there's a huge opportunity, and I'm really excited every time I see a new seaweed startup that's working on developing these new materials or taking fractions from the seaweed and applying them in high-tech ways, right? So all the alternative bioplastic companies that are developing products is, I think, the future, right? Because it's really hard. I think it's a really uphill battle to take seaweed and try to get Western consumers to eat it whole. Food culture is one of the most deeply entrenched parts of our culture, and it's just really hard to, if people don't have a taste for it, it's just really hard to force that change. So we need to be more creative, and I think the way forward, at least in the Western world, is to do sort of what we're doing and what a lot of those other companies are doing, which is find a way to take it apart and put it back together in more appealing ways. And then also, again, there's that opportunity to develop new cultivars that have different properties that are fit for purpose. And so I think that is definitely the path forward for us and for a lot of these other companies.
Can you tell me a bit more about those new cultivars? So tell me a bit more about
the process of thinking around species that we can potentially cultivate, and also room for introduction of invasive species. What's your thoughts with that? For example, if you were to cultivate something on a land-based facility that might not necessarily be from that area, is that something that you guys have considered, or have you got a firm stance on that topic?
Yeah, well, I think really that's a really great question. It's something we've thought a lot about. Periodically, I evaluate the opportunity for land-based cultivation of seaweeds because we could get the protein up in multiple ways, right? One is just higher nutrient addition, which is sort of the first level, and getting a higher protein content. The cost of tank cultivation is at least an order of magnitude higher than ocean-based cultivation. And so every time I look at it, I say, well, until there's some sort of key technology change that changes the fundamental economics of that, we have to look to the ocean for large-scale protein farming. And for that, we're constrained by the species that are available in the geographic region. So a great example of that is wakame or undaria. So that is a seaweed that actually has quite high protein levels versus other species of brown seaweed. So in Asia, most wakame is like 15 to 20% protein, which is considerably higher than what we see in most kelp species. So that would be a great species to use to boost protein, but it is an invasive species in most other regions. So some of the red species I think would be the ideal targets in other regions like Gracilaria, which is native to most regions in the world. They have their own geographic species, but I think that would be one where you could apply the same breeding techniques to different species that are native to each area.
I was going to say, when you're talking about Undaria, I was thinking, oh gosh, that's from the Pacific, isn't it? What's acceptable? Where can you draw the line?
I think it's important to just say, anytime you're farming, I think for the right reasons, the people that are in this community, want to do it the right way and want to do it in an environmentally responsible way. That being said, you have to acknowledge that anytime you're farming, you're changing the environment, right? So you can't, generally, the great thing about seaweed farms is that they provide habitat to native species. You're growing essentially a forest and an ecosystem, but it is a managed forest, right? And so I think there's going to be trade-offs there, but I think we have to be careful as an industry not to promise that we're going to do everything for everyone, right? It's not going to be a natural kelp forest. It's a managed farm. But I think one of the things that we've been developing over the last couple months is a really powerful thesis around the potential of shifting our protein production from land to sea. So there's a recent analysis in Nature that calculated that if we can remove just 15% of degraded cropland and return it to nature, that would sequester 300 gigatons of carbon from the atmosphere. And that's 30% of all the emissions since the Industrial Revolution. So how do we do that? Well, one of the ways is we just reduce our pressure on our land use for protein. And most of our cropland goes in one way or another to our protein supply, either growing livestock or growing the crops to feed livestock. So we're working on that in one way, right, by developing a plant-based meat product. But one of the other ways so reducing our demand for animal protein is one of those huge ways. But another way is to just reduce the pressure on that by shifting that protein production to sea. And we can produce all the world's protein needs with just 1% of the ocean. So I think that's really powerful framework for us towards thinking about the potential of seaweed farming. Not as we did look at sinking seaweed, which works. It's just very economically challenging, right? And probably not the best use of seaweed. But an even greater impact on the carbon side is actually that shift of protein production from land to sea. And that's something that we're just starting to now talk about and communicate, because if that works, it'll be one of the most radical transformations in agriculture since the Green Revolution.
You make a very strong argument for it, which is excellent. But I have a question, which is obviously lots of focus on proteins, but that's only one fraction of seaweed. Are you interested at all in carbohydrates or pigments? Is that going to be the next stage, kind of like a biorefinery? Is that somewhere you'd like to go with your company, or?
Yeah. So actually, our bacon is a great example of that, because we're using both of the two principal fractions, which are the protein and the hydrocolloid gels. So carrageenan, alginate, agar are the three sort of main hydrocolloids that are produced commercially. So right now, we use those hydrocolloids in our bacon as fat encapsulators, and we also use our protein. So the bacon is actually a great physical demonstration of how you can separate the seaweed into its component parts and then reintegrate them in a way that is appealing and delicious and value added. So yes, so our goal is to have a facility that separates seaweed into protein and hydrocolloids and have both of those as revenue producing product streams. And so we see seaweed, in a lot of ways, we're saying seaweed is the new soy, but it has the same properties of having favorable unit economics because it has these two valuable co-products. So in soybeans, it's the protein and the soybean oil, but in seaweed, it's the protein and these hydrocolloid gels that are actually polysaccharides, but actually make for great fat analogs and also great biomaterials as well.
Talking of unit economics, price point for production, is this something, obviously, if you wanted to compete with soy, I'm not sure if that's still the objective for you guys because of the low price of soy. You're going to have the price of production has to decrease significantly. And I know you guys are making great progress with your production plan to then bring the price down for extraction and purification. So can you give us a bit of an update on that front and what your thinking is currently on that? Is that still an objective based on you guys make a really great premium product? I'm assuming there's a green premium on that compared to bacon, right? So how do you think about that price, the price of production, and how much further do you have to bring it down to start to move the needle with a comparison against soy?
Yeah, so there's three sort of key levers or I'd say factors that go into the cost of protein from seaweed or from anything. And so one is the cost of the raw material. The next is just the protein content in the raw material. And then the third is your extraction yield. And I'd say actually a fourth is even co-product value, right? So the one thing that the two things that factor into that we're not currently doing is, right, lowering the cost of the raw material. The farming technology we developed will directly lower the cost of seaweed. So that is a key lever. The next one, as I mentioned earlier, is developing high protein strains of seaweed, which is, I think, some of the low-hanging fruit because no one's really tried. And I think if we do a focused R&D effort and get some smart people working on it, we can make a lot of progress in a short amount of time. And then, of course, we are working on extraction yield. And then, there's already a market for those co-products, but in order to match the volume that is, when you talk about scale and you're saying, okay, well, we want to match soy at scale and cost for protein, there's a market for protein that's that big. But right now, the market for hydrocolloids, they're specialty chemicals. So we need to find new applications for those hydrocolloids that can scale along with protein. And I think people are doing that right now.
Where are you getting most of your seaweed from now? Is this are you collecting it from the US, or do you have to bring it in from Asia to meet demand?
So right now we're using nori, which is from Korea. Yeah. And then our hydrocolloids, we're using carrageenan and agar in our bacon. And so we source those from ingredient suppliers. And as you probably know, most of the carrageenan seaweeds are grown in Southeast Asia. So right now the seaweed supply is, and I think for the near future, if we want to do anything at scale, we're going to be sourcing from, and those are both red seaweeds, right? That are, I'm really excited for the work that we're doing right now in the lab. And we just got additional funding from the DOE to continue working on brown seaweeds like kelp. I'm really excited for the technology to unlock kelp as a protein source. So that will require better fractionation technology that we're working on and higher protein contents.
Yeah.
And as soon as that will really unlock the US and Europe as major protein producers.
So you have some belief in the emerging regions of cultivation, which is good to see.
Yeah, we have to apply technology to those industries for it to work.
Mm-hmm.
Like for it to work at scale, right? If we want to move what's right now sort of cottage industries into the types of industries that can scale and produce volumes of materials on a meaningful quantity that will have impact on our GHG footprint and diet, we have to apply technology to those industries just as we have in terrestrial farming.
Going to, unlocking kelp as a protein source between species, different proteins, different qualities, different tastes. How does one even begin to get through that jungle?
So the most important thing generally when you're looking at protein quality is the amino acid profile. And so there's 9 essential amino acids we need in our diet that we don't make ourselves that we need to get from food. And so seaweed is considered by the FAO as a complete protein source because it does provide all those 9 essential amino acids. So starting off with, and people have been eating seaweed for millennia, and part of that is because it has such a great nutritional profile. Some of that comes from the amino acids, some of it comes from other compounds in seaweed, but the protein content is low, but it's high quality, right? So I think we're at a good starting point to where we boost the protein content. We have a great product.
And I got a question because you guys seem to be doing so well, especially in retail markets and the US market with your product. How have you guys gone about your sales process to come into contact with some of these big shops and actually sell your product in stores? What's the actual system in place to finding and selling these products?
Yeah, sales, as anyone coming in from a science background, getting into the sales cycle is a learning experience. And, I'd say we thought really long and hard about our business model. And, we started off as a protein company. And then I remember we were pitching Vinod Khosla, who's like sort of one of the legends in Silicon Valley. And he said, you'll never be $1 billion company if you don't have a branded consumer product. And so we
that categorically, but just for you or for any B2B business in this space?
That's what he told us.
Yeah.
And so, because he was they look at the revenue potential, right? Mm-hmm. And it's like, can you get to $1 billion in revenue? And so that forced us to look at, okay, well, rather than be a B2B protein company, what if we put the protein in something? And so that was sort of the origins of the bacon. And also what could we do with these hydrocolloids, right? If we're a seaweed company, like how can we combine the protein with the hydrocolloids to make something interesting?
To cross a variety of different functions to do that. You have to be designers, you have to be food designers. This is a massive undertaking. Is this just about building a great team, or do you have to do a lot of upskilling as well?
Yeah, I mean, we've done a lot of it ourselves, but we also, we're only 4 people still. And one of the things that has worked really well for us is outsourcing. When we came up with sort of the base formula for making a crispy, fatty bacon, but then we hired, rather than bringing in we don't have a food scientist on staff. We hired, Oregon State has a great food innovation program. So we hired them on contract to basically improve the flavor profile of the product. And we've done that as well with our pilot scale manufacturing. One thing, I'm really glad we did not do was build our own pilot scale manufacturing facility, which would have cost, at least like $1 million. And instead we were able to find a university that had all the equipment that we needed. And they had different kinds of equipment so we could test it, a couple $1,000s a day. we were able to get a lot of information in just a couple of days. So
with no patent IP issues.
Those universities are set up so that you own any of the IP that you develop. And generally by the time that you're there, you're just testing out the process you've already developed at lab scale. Usually not a lot of experiments happening. You might try like 3 different types of centrifuge, for example.
That's really interesting.
And that's personally exists to help small companies scale up. It's very hard for us to find. Like we didn't even know it existed, and it just we just happened to write enough emails, and a new person was at this university. It was Iowa State actually, that wanted to work with startup companies, and so it was serendipity. But finding the right partners is a big part of it. It was the same thing with our manufacturers for the bacon. Basically, we had to cold call and email like 100 different manufacturing companies, and most people weren't interested. A lot of commercial entities are just not interested in working with startups, right? Because what do you have to offer, right? So it's a lot of just grunt work of going through lists and talking to people. A lot of places that you need don't advertise what they're doing either. So it's a lot of just grunt work and networking and asking people who they know who might be able to help you with your scale up.
Because this is an attractive model, right? Outsourcing, I think it can be cheaper. You could scale faster. You can get proof of concept. So how did investors react to that type of approach, and how common is it in other companies that you've seen in the space?
Yeah, I think, we really leaned into the fact that we went from bench scale to commercial scale. And, we manufactured our first protein run in a facility that does thousands of pounds a day of pea and soy protein. And we did that scale up in a year, which is dramatically fast, right? And we were only able to do that because we followed this outsourcing model. And I should say, because we designed the process from the very beginning to we didn't even consider or test processes that couldn't be done with existing industrial scale manufacturing equipment. And I think that's a lesson. I know, like my friend Julia Marsh at Sway, I'm not sure if you've ever talked to her, but that was like one of the things. She's like, we got to develop a material that goes into existing infrastructure, because to build our own thermoplastic manufacturing plant will be, probably a couple $100 million, right? So I think that's a really important in the design phase of your process design is think about the technologies that are out there and try to work on something that can be done in those facilities, even if it's a little bit less efficient or a little bit slower, because you'll be able to scale a lot faster.
Mm-hmm. When you were doing your commercial roadmap for investors, how did you go about showing why you're picking this product at this price point? Was it a comparison of market TAM, market size, and price point, or were you looking at constraints for different applications in the short, medium, and long term? Was there any process there, or how difficult was that? Or was it a pitch deck? It's a few slides of why, running them through bullet points, or was there another way that you went about doing that? Does that make sense?
Yeah, so I think we always start with, and I've learned this the hard way actually when we haven't done this, but I've always started with the big opportunity, right? Seaweed is the world's future protein, right? And bacon is the tip of the spear. It's the way we're introducing people to this protein. But we also, as much as investors will say, oh, we're looking at the big picture, or the $1 billion opportunity, they want you to make money in the near term as well. And so, why bacon? It was partly just serendipity that we managed to find a way to hold on to a lot of fat in our formula and make a crispy bacon, which wasn't available really on the market at the time. And, you have to also sort of follow the trends in VC investing if you're going for venture capital. And plant-based protein was super hot at the time. And so it just seemed like a good application of the protein to be putting into something that was a very common food product where we didn't think there was very good competition on the market. Mm-hmm. So it's of opportunity and what's the technology that we have
Yeah.
at hand.
But in the interest of time and your time, one of the questions I sort of posed to you was this mistake question. Would you be comfortable sharing one of your biggest learnings in the last few years and one of the mistakes that you could reflect on?
Yeah, so I think it's interesting. Our mistakes have always been something that I'm happy we learn from, because as long as your mistake doesn't kill you, then it really makes you stronger, right? So I think, well, the first thing I already mentioned was something we almost did but didn't do, which was build a pilot plant, right? That would have been a big mistake. I'm glad we didn't do that. I think, and towards that, anything that requires a very large upfront investment is dangerous as a startup because it prevents you from pivoting, right? And so there was at one point we signed a contract that we had to get out of, like a long-term contract. I'd say be very careful about that. But in some cases you'll need to sign a long-term contract. So that just might be for our particular situation, right? When you're working with a manufacturer, for example, it can be in both of your best interests to sign a long-term contract. But think of all the things that might go wrong or that you're not expecting, because they probably will happen. And I think that's in general in startups, things never go according to plan, right? And so it's hard to think of like mistakes, because a mistake assumes that you have all the information, right? And in hindsight, maybe it's a mistake, but by definition, if you're a startup, you're doing something new that no one's ever done before. So it's also hard to know if something was a mistake or not. But, we've definitely learned a lot of lessons. And I think fast iteration, I mean, this is nothing new, right? The lean startup methodology, just test, do as many cheap experiments as possible. It's much better to get 10 results at like 50% accuracy than invest in one long experiment. And I should say time is super important too. You asked me earlier about business models. And one thing I didn't consider, which we've now learned is really important, is sales cycles, right? If you're a startup, you take investors' money, you have to achieve results in a certain time frame, a pretty short time frame, right? And if your business model requires selling to customers that take a year to make a decision, that's a huge rate limiting step, right? So think about business models. I think that was one of the reasons why we entered the restaurants instead of grocery stores, is because it's super easy to walk into an independent restaurant and talk to the chef and they'll say, sure, we'll put it on our menu next week because we like it. Whereas, grocery stores are a little bit longer. As we're learning now, the big accounts, like the big chains, right? Those are even longer than the grocery stores, right? Because there's a lot of, basically, take a look at how many decision makers there are and how many gatekeepers there are, and like multiply that by,
Yes.
That was the most frustrating thing, as well as trying to be an ingredient company. That was one of the reasons why we pivoted away from being an ingredient company, is because, if you want to be a successful ingredient company, that means you need to work with a big company that has large volumes, like a Cargill, right? Think about how long it takes to get into it.
Yeah.
Like this launch. So I think that was a really important lesson for us, and one that we're still learning. And then what else can I say? I think, just being lean, right?
It's tough to be lean with a deep like algae tech, seaweed tech, right? You have some capex and opex, right? So
yeah, a lot of what we've seen in the last year is the venture funding environment has totally changed, and what generally happens is people spend the money. You're expected to spend the money that you're given by investors. But I think another benefit of the outsourcing model is that it's easier to turn off and save cash when you need to, when you don't have, when a lot of core functions are contracted out versus building a big team. So we have a very lean and nimble team. And I'd say each person on our team does the jobs of about 5 people.
I believe that. And my last question was around advice. I mean, you've offered some great advice already with these learnings. Is there anything else in particular that you would tell yourself 1 year ago, 2 years ago, that would have changed the trajectory maybe, or you just would have said it all the time?
I don't know that there's anything, sort of, because I was saying before, it's hard to know what would have happened in an alternative situation. I think in general, by staying lean and nimble, we've been able to follow the right path in most junctures. What I will say is sort of what I think is really important, especially for people coming out of science backgrounds and going into business, is just understanding the core fundamentals of sort of the economics behind a successful business. And so before I started this company, I was actually working at an organization called Activate, which supports science entrepreneurs, and developed a resource there. They have a whole bunch of resources that I'd highly recommend for anyone who's in science, who's thinking about going into any type of commercial or even commercializing something or developing a technology in a academic setting that they hope can be transferred to industry, even if not by themselves, is understand the cost drivers of this technology, know what CapEx, OpEx, and internal rate of return mean. And so, I'd highly recommend that anyone to go to the activate.org website and do tools for innovators. That there's a whole bunch of tools for people who are coming from science backgrounds to learn how to start and analyze a technology opportunity from a business perspective.
Fantastic. And my last question is, where can you get the inspiration to finally make the jump into just be like, right, let's just do it? I feel like that's something I've heard. I'm a little bit younger, but for my friends, we want to do something like a startup, but none of us are brave enough just to start. What is it that you just have to persuade yourself or tell yourself to really make the jump?
I know you gotta have a risk tolerance, right? And you have to have a sort of the financial cushion, honestly, right? Like, it's helpful when you're young, you don't have a family to support, but if you want to do it, like, if you're thinking about it, you should do it, right? Because there's probably not going to be a better time. And do early experiments and be willing to fail and change. I think those are get proof points very quickly, ways where it can validate or invalidate your hypothesis, which is
And sometimes, like Enrico, as you get further into the domain, you'll have more ideas, right? I think it's sometimes you guys are overly eager to jump into stuff and you haven't necessarily got the knowledge.
I have no idea.
Yeah. Anyway, thanks so much for your time. It's been a pleasure to catch up. Thanks so much for jumping on with us. We really enjoyed it. And
that was awesome.
Yeah, thank you so much.
Thank you.
Yes,
Bye there.